In recent months, alarming footage has been appearing online more and more often. Humanoid robots moving in formation, training grounds, automated combat scenarios. Formally, these are demonstrations of robotics capabilities and simulations for scientific research. But an increasing number of analysts say that China is entering a new phase of militarizing AI and humanoid platforms. Officially, Beijing states that humanoid robots are being developed for industry, logistics, and the civilian sector. However, behind the scenes, something else is happening. Chinese military research centers are actively investing in intelligent ground platform projects, robots capable of operating within units, conducting reconnaissance, accompanying soldiers, and working in dangerous zones. And here it is important to note, this is not about replacing the army with robot soldiers, but about creating hybrid units where machines enhance the capabilities of human fighters. According to open sources, China has been developing the concept of a smart battlefield for several years. This is a system in which AI analyzes the situation in real time using data from drones, satellites, ground sensors, and robots. Based on this, algorithms suggest optimal decisions to commanders. Within such an architecture, humanoid robots are viewed as mobile nodes, carriers of sensors, manipulators, and communication systems. They are trained to move across difficult terrain and operate in conditions of smoke, debris, and urban environments. The footage currently spreading online under headlines about the first units of a humanoid army is in fact demonstrations of laboratory prototypes and field tests. However, insiders in the robotics industry claim that some of these projects are funded through related defense programs. Formally, they are classified as dual-use technologies for rescue teams, facility security, and work in emergency zones. But the same navigation, coordination, and control algorithms are applicable in military scenarios. The key technology here is not the robots themselves, but the centralized AI control loop. China is actively developing swarm control systems for drones and autonomous platforms, and the same approach is being scaled to ground robots. In the future, AI does not command the army, but acts as a super analyst, forecasting risks, distributing tasks between robots and humans, optimizing logistics and evacuation. This makes military structures faster and more resilient to battlefield chaos. A separate topic is preparing soldiers to interact with machines. China is already running large-scale programs to train military personnel to work with robotic platforms, control, escort, tactical coordination. This resembles how armies once adopted drones, first as an exotic tool, then as a mandatory element of units. Today, in such scenarios, humanoid robots are viewed as smart partners, carriers of equipment, scouts in dangerous zones, mobile platforms for sensors and communications. It is important to understand that no country officially declares the creation of an army of humanoid soldiers. This is an extremely sensitive topic from the perspective of international law and public perception. But the race for autonomous military systems is in full swing, and China is among the leaders. At the same time, the US, Europe, and other countries are developing their own programs, from autonomous ground platforms to AI-driven battlefield management systems. The difference is that China emphasizes scale and speed of deployment, testing technologies directly in field conditions. Looking more broadly, we are witnessing the beginning of a new era, the era of hybrid armies where AI and robots become as fundamental as armored vehicles or aviation. This does not mean that units of Terminator-like machines will enter the battlefield tomorrow, but it does mean that machines will increasingly take on the most dangerous tasks. Reconnaissance under fire, delivering supplies to hotspots, operating in zones of chemical or radiation contamination. And here the main question arises: are societies ready for such a future? The mass deployment of autonomous combat systems raises issues of ethics, AI control, and responsibility for decisions made by algorithms. While governments argue over rules, technology is advancing faster than any international agreements, and footage of humanoid platform training, even if still experimental, is already a signal that the world is entering a phase where AI becomes a full-fledged participant in military systems. In fact, We are on the threshold of a moment when the war of the future will be defined not by the number of soldiers, but by the level of autonomy, the quality of algorithms, and the speed of data processing. And China, judging by current trends, is doing everything not to miss this window of opportunity by investing in robots, AI, and the infrastructure for managing autonomous systems. There is another layer that rarely makes it into the frame: the economy and production chains behind military robots. Any autonomous platform is not just a chassis and servo drives, but also batteries, computing modules, sensors, communication systems, software, and continuous AI updates. China is building these chains as a unified industry. Actuator and battery production is scaled domestically. Chips for visual data processing and navigation are optimized for swarms of devices, and software is developed according to the principle of continuous learning from real-world operational data. As a result, each new batch of robots is released not simply as a new hardware version, but as a carrier of improved algorithms accumulated by the entire ecosystem. Special attention is paid to the resilience of autonomous systems to interference. In real scenarios, whether rescue operations, emergency response zones, or military exercises, communication is unstable, GPS may be unavailable, and visual landmarks change. Therefore, modern humanoid platforms are trained to operate in partial autonomy mode. Local perception models allow navigation without constant cloud access, and distributed communication protocols enable coordination even when channels degrade. This is critically important for any swarm systems. They must maintain functionality even with the loss of individual nodes. At the same time, the field of simulation is developing rapidly. Most AI training takes place not on testing grounds, but in virtual environments where millions of scenarios are played out in a matter of hours. This accelerates progress dramatically. A robot lives through thousands of virtual missions before entering the real world. China is actively investing in digital twins of testing grounds and urban districts where AI practices navigation, interaction with people, and coordination with other machines. In reality, we see only the tip of the iceberg, a polished field demonstration, while the core work happens in data centers. There is also a geopolitical second-wave effect. As soon as one country demonstrates scalable autonomous systems, others are forced to accelerate, triggering a chain reaction of investments. The US, Europe, Japan, and South Korea are increasing budgets for ground autonomous platforms, drone swarms, and AI-driven control systems. As a result, a new race is emerging, not so much a traditional arms race, as a race for autonomy, whose algorithms learn faster, whose systems are more resistant to interference, whose production scales more rapidly. But this race also has a shadow side: regulation and responsibility. When decisions are made by algorithms, the question arises: who is responsible for a mistake? The developer, the operator, the commander, the state? International norms on autonomous systems still lag behind reality. Technologies are already capable of operating in complex environments, while the rules governing their use remain fragmented, creating a gray zone where experimentation advances faster than limitations are formed.